Swayam Prabha. Digital India. Educated India.
Hello all, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are covering projection of solids. In today's class, we will look at more complicated three-dimensional objects when they are inclined towards the planes, how to draw those pictures. For example, here we have a pentagonal prism which is placed with an edge of the base on horizontal plane such that base or axis is inclined to horizontal plane. So, either the base is a pentagonal prism, that means phi size is entire base or axis whatever might be, that is inclined to horizontal plane. Now, this axis is neither perpendicular to vertical plane nor to this horizontal plane. So, slightly tilted kind of thing. Okay. For example, if we are picking this pentagonal prism, in one of the view, maybe the axis, especially in the front view, because axis is inclined to horizontal plane, that we can observe only in the vertical plane, front view. So, in that front view we will see this axis is inclined to horizontal plane. So, after drawing we see that the prism perhaps inclined in that way. If that is the case, if we are looking at top view, it will not give us straightforward pentagon or perhaps something like a rectangular box, something like this kind of object shape we will see. How to do that step by step, that is the thing what we are going to learn it in this lecture. So, to do that inclined axis, first of all what we will do is, we will construct a pentagon resting on this horizontal plane. So, the edge, one of the edge, we make sure that it will be perpendicular to vertical plane. So, it is more like if we have this prism, first what we will do is, we construct in such a way that this entire prism, so in the top view we will see something like such kind of thing. So, where axis is perpendicular to HP, then what we will do is, we will rotate it in such a way that this axis make an inclination angle perhaps in that way. So, this entire object tilted in that direction, that is the way we would like to do. To do that, first of all in the top view on the horizontal plane, we draw a pentagon where one of this edge or surface is perpendicular to vertical plane. Now, the projection, if we are drawing this entire pentagon in this view, front view, if we are looking from that, this line coincides with that one edge as a surface. This entire surface coincides with this surface. And it is resting on horizontal plane. So, this line always coincides. Now, what we want to do is rotate this entire object in this direction. That means basically the axis what we are having dash dot line, this has to be rotated in that direction. So, all this line has to be rotated in that direction. This entire line has to be rotated in that direction, and this one also in that direction. In that way, if we can make it, our axis goes in that way. So, when we do that, first of all we draw an axis making certain inclination angle, maybe if it is making 45 degrees, at 45 degrees first we draw an axis. It is rotated about this point, so this point always be resting on that. Using our compass, whatever this distance, that distance we make an arc perpendicular to this axis and join that line. Similarly, when we are rotating this entire thing, this AB line also gets rotated. To do that, what we will do, C1 to C prime, whatever that distance, we make that same angle. So, if this is 45 degrees, let us consider this one also 45 degrees line, we will draw it from this point. Transfer this length in this direction. Similarly, transfer this length in this direction. Similarly, transfer that length in this direction with the same 45 degrees angle. So, we have tilted that prism which can be visible in the front view. Once that is done, we transfer all these points onto horizontal plane down. So, these points transferred in such a way that this line maps to that, this one maps to that, and whatever the B1 points and so on. So, in this way we map these lines, map these points, whatever those intersection we are having. From that we will be in a position to construct this pentagonal prism. Any invisible sides, we show them by dashed lines. In that way, and this is a continuous line. So, this pentagonal prism which is whose axis is making an inclination angle with the horizontal plane, in the front view looks like that and in the top view looks like that. Let us look at another example. A hexagonal pyramid, when it lies on horizontal plane, on one of its base edges with its axis or the base inclined to horizontal plane. So, we have hexagonal pyramid and it is resting on horizontal plane. 6 sides will be there and one of these base edges with its axis also inclined to horizontal plane. So, we have to construct in such a way that base and axis are inclined and edge also supposed to be inclined. So, let us look at that example. So, it is a hexagonal pyramid. So, 6 sides are always be there, those 6 sides. It is a hexagonal pyramid. So, all the inclined faces will be visible in the top view. So, continuous lines we will show, and its projection as a triangle. and one of these line coincides there. Now, axis has to be inclined. So, this is the axis, this we rotate it. So, this axis if we are rotating by a certain angle, it goes in that way. Transfer this length normal to that. Similarly, transfer these lines in that way. It is more like from here measure the distance, make an arc. Similarly, from here whatever that distance, make an arc from that point. So, intersection point join it, so that we will have this part. Now, transfer all these points on the horizontal plane. Similarly, transfer these points on this horizontal plane thing. These points intersect at this level. Now, identify the lines which are visible when we are looking from this direction. We will be definitely seeing A prime O prime lines. That means, A to O will be visible. Similarly, F prime O prime, that phase also visible. So, it will be that. Definitely A to F prime, whatever this line we can see, that is also visible. Now, B surface B to O, when we are looking from that direction, that is also visible. A to B surface also visible. Similarly, F to E surface, so F back side of that E is there, that is also visible. F to O also visible, and that E point to O also visible. So, this is the way cone really looks like in the pyramid, and the other internal things at back side of that is not visible. So, it goes in that way, and this C to D line also invisible. So, we will have that dashed line. So, the overall construction gives us the front view looks like an inclined one, and the top view makes this obscured kind of pyramid. Now, let us look at another example. A hexagonal prism has to be placed with a corner on base of the horizontal plane, such that base or axis is inclined to horizontal plane. Think about it, what are the points resting on horizontal plane? Is the axis inclined with the horizontal plane or vertical plane? In what sense? And corner of this hexagonal prism of that base is on HP. So, let us look at that example. So, first is a hexagonal prism. Whatever might be the inclination angles, first begin with the picture, then suitable rotations we make it, so that the given conditions will be met. So, first draw a hexagonal prism. In the front view, it looks like a rectangle. This face entirely we can see goes in that way. Axis is invisible, so dash dot lines. and axis is inclined to that horizontal plane, which we can sense it only in the front view. So, axis dash dot line. Transfer all these lines so that we will see this one. If we are carefully noting, corner of that base is always be resting on horizontal plane. That is the reason we made it to rest it on this horizontal plane, and this corner still rests on that horizontal plane. So, this point always be on that ground. Now, project these points all the way from top view on the from the front view and also from this direction. From here transfer the points so that it intersects. So, one has to be careful. Let us transfer A from this direction, it goes somewhere. Similarly, A1 prime, transfer it where they are intersecting. First locate that point A, then move from B where they are intersecting, locate those points, this one, this one. Similarly, C map to that point, C map to that point, D, E1, F1. Similarly, on the other side, A prime, E prime, C prime, D prime points gives us this information. When we are looking from top view, this entire plane will be visible. So, that one what we are seeing it as a hexagon. When we are looking at this, most of this hexagon is invisible other than the edges. So, internal things are invisible. So, that is the reason we have this one, and this one is visible. So, we have a continuous line. These edges are also visible, that is the reason these are continuous lines. Let us take one more example. It is a hexagonal pyramid. Pyramid means we have this apex or vertex, and it is placed on one of its triangular faces on horizontal plane. So, we have a pyramid which is laying on that horizontal plane. So, the faces always be touching that horizontal plane. If that is the case, what we have to do is first rotate it in such a way that it is resting on horizontal plane with its base. So, when this pyramid, hexagonal pyramid, resting on horizontal plane with its base. So, in the top view we will see this hexagon in that way. Axis goes all the way through O. Project it so that in the front view we will see it like a triangle along with this additional edge. When we are looking, this entire edge will be visible here. Now, rotate in such a way that this axis makes an inclination angle with the plane, horizontal plane, and one of the edges will be resting on this plane. One of the edges, if we are looking, this is one of the edge. If I am rotating it in that direction, this O prime C prime edge has to be resting on the ground. So, O prime C prime, we draw it. Measure O to C prime, locate O prime C prime, draw that. Now, transfer this AD prime in this way. From here measure the thing, whatever that length, make an arc, because this entire thing. From here also measure this one, make another arc. So, once we have that point, connect this by triangle. Once we know that this length which is at middle, the same thing we can connect it, so that we can make that triangle. Once we have that, transfer this point projections vertically down. Similarly, we have these points E, B things, those are also projected in that way. In that way, we can locate point A, B, C map to C, D, then E point maps to E, and F point. Already O point we transferred it. Once it is done, we connect, join whatever the visible faces. So, visible face is always be AO face, so visible one, and this one also visible BO thing. So, that is also we will connect it. Similarly, on the other side, E thing will be visible. Similarly, F thing will be visible. And when we are looking from top view, this A to F line always be visible, we join it, and C to D also visible, so we join that. Now, when we are looking from C, this point E is connected, so that and this one will be visible. The remaining lines are always be invisible, so we show it by dashed lines. Let us take another example. Draw the top and front views of a rectangular pyramid of sides of base 40 by 50 mm. It is a rectangular pyramid. That is the reason you have different sides, different lengths 40 and 50 mm, and it has a height of 70 mm. When it lies on one of its larger triangular faces on horizontal plane, because it is a pyramid, we always have this apex vertex and base might be rectangular thing. When you are connecting this base all the way to vertex, we will see triangular faces, and the larger triangular faces, that is on horizontal plane. Further, the longer edge of the base of the triangular face lying on horizontal plane, and it is inclined at 60 degrees to vertical plane, and that is visible in the top view, with apex of the pyramid being near to vertical plane. So, when we are constructing this, first of all, based on the conditions, we have to visualize how the object might be looking. If you are looking carefully at this last point, the apex of the pyramid being near to vertical plane, that gives us preferential direction already which way we have to orient this pyramid. So, the apex always be near to vertical plane. So, we have to make, if this is the vertical plane, if this one is apex, it has to be brought in that way. It might be in that way, it might be in that way, but this apex has to be in that way, but it should not be something like that. And second condition, if we are seeing the longer edge of the base of the triangular face lying on horizontal plane, and it is inclined 60 degrees in the top view. So, when we are seeing the longer edge of the triangular face, that makes 60 degrees with this vertical plane. With that visual, we can easily recognize how this pyramid is inclined. So, let us look at that. first of all we may have to do multiple rotations. So, the easiest way is begin it in such a way that we will be drawing a rectangle. It is a pyramid, so edges will coincide there. Let us use some other color, black. The front view projection is a pyramid, so we will see it like a triangle. This one, when we are looking this direction, coincides with this triangular face. Similarly, this one coincides with that triangular face. Now, it is lying on horizontal plane with this part. So, what we will do? O to B prime, first of all we locate it on that horizontal plane. Then transfer this A point precisely to that location. Then project all these points down. Similarly, project these points. Then we will have the prism, the pyramid. In this way it looks like in the top view. The remaining things are dashed lines. After that, what we have to do is this longer edge makes an inclination angle with the vertical plane. That means, we should not see it in this way, it has to decrease its length. It is more like this is the one we want to decrease when we are rotating. Longer edge length decreases in your view. For example, this is the longer one, we want to decrease that length so that it makes an angle with the vertical plane. That we can see only in the top view. So, what we do is, when we are doing in the top view, we construct in such a way that it makes an angle. So, this entire object is rotated in such a way that the same thing, rotate it, draw it and transfer this length. When we do that, the inclination angle we can sense the longer edge how it is going to make with vertical plane. So, this one we rotate it with certain angle. Then we project those points in the upward direction towards this. And this one what we are rotating. So, project these points. When we do that, C point and C point coincides there. B point and our B point coincides there. So, join by a line. Similarly, A point and A point coincides there, connect that. Similarly, D point, this one and this D point coincides. So, join by line. Now, this O maps to there, join that. That means, we have a front view where this longer edge makes an angle with the vertical plane, and the remaining lines will always be dashed lines. This is the way we construct this top, this is the top view and this is the front view of a pyramid whose longer edge is making an inclined angle with the vertical plane, and its longest edge is resting on the horizontal plane also. Now, let us look at the last example. Here, a cone of base 80 mm diameter and height 100 mm is lying with one of its generators on the horizontal plane. So, a cone generator has to be on the horizontal plane and its axis appears to be inclined to vertical plane. So, when we are looking at that, let us pick a cone, maybe first fix in such a way that the entire circle in the front view we can see that turn it in that direction. So, the generator will be resting on horizontal plane, then rotate that cone in such a way that that axis line makes an inclination angle with the vertical plane. So, how to construct that? Let us look at that example. That we have to do step by step. First, what we are doing is a cone resting on horizontal plane. This is the thing. If we can construct it, then we will make a rotation so that generator will be lying on the horizontal plane. To do that, first of all, make a cone resting on horizontal plane so that its axis is perpendicular to horizontal plane. So, axis pass through that, passing perpendicular to this plane. Have a front view which looks like a triangle. Then rotate it in such a way that one of the generator may be OG prime resting on the ground. So, once we draw OG prime resting on the ground, we can always locate a point by compass. Once it is done, we can project this point all the way down, project all the way down. It is a circle. So, we divide that into 12 equal parts, 8 equal parts and project these lines. So, that when we are projecting this line also into 8 equal parts, finally, we will be in a position to construct an ellipsoid. Join that so that we got a cone resting with its generator on the horizontal plane. Once it is done, its axis, if we are seeing that, is still making an inclination with the horizontal plane, but it is parallel to vertical plane. So, we have to rotate that apex or perhaps that cone on the generator, so that axis itself makes an inclination angle with the vertical plane. That means, rotate that in this direction, so that axis is inclined to vertical plane. This inclined to vertical plane we can see only in the top view. So, perhaps the inclination angle 40 degrees. Now, again transfer this ellipsoidal, the points, whatever those 12 points or 8 points we made on the circle. Now, it looks like ellipsoid, transfer these points all the way up. Similarly, transfer these 12 points. Then we will have the projected one as an ellipse and join this line. This is the way we draw top view and front view of a cone whose generator is resting on the horizontal plane and its axis is making an inclination angle with the vertical plane. And this problem, work it out as a homework, where a triangular pyramid of edge of the base 20 mm and length 30 mm is resting on a side of the base horizontal plane. The axis of the pyramid is inclined at 45 degrees to that horizontal plane and 60 degrees to that vertical plane. If that is the case, draw its projections. Okay? Thank you very much.